Okay, so dear student, this is our next class. Now in this class we discuss about the factors on which resistance of a conductor depends. As we know that in a previous class we studied the definition of resistance, and from Ohm's law we get the definition of resistance, and that is denoted by R, and its SI unit is ohm. Now this resistance depends upon some factors. In this class we discuss about that factors. So what is these factors? First factor is length of the conductor. Length of the conductor is directly proportional to the resistance of the conductor. That means if we increase length, resistance also increases. If we decrease length, resistance also decreases. Okay, so suppose this is one conductor, conducting wire. If we increase its length from here to suppose this up to this, okay, so its resistance also increases. But if we decrease its length from here to here, here to here, so resistance also decreases. So we can say that length of a conductor L is directly proportional to R. This is the first factor. Second number, area of the conductor or area of cross-sectional area of the conductor. How they related to resistance? The area of conductor or cross-sectional area of a conductor inversely proportional to the resistance. Area is denoted by A, so resistance is inversely proportional to area. Resistance is inversely proportional to area. So what does this mean? That means if we increase the area, then resistance also decreases. If we decrease the area, resistance increases. For that example, if we consider two wires, one having small cross-sectional area means this one, okay. Another conducting wire has large cross-sectional area. Two types of conductor. Now, in which conductor resistance is maximum and in which conductor resistance is minimum? As we know that if area, cross-sectional area increases, that means or more. In this figure, cross-sectional area is more than this one. So resistance is less. But here cross-sectional area is decrease or less. So resistance is increases. So if you have a thin wire and a thick wire, so the resistance of a thin wire is more than the thick wire, because in the thick wire cross-sectional area is more than the thin wire. Okay, so area of a conductor is inversely proportional to the resistance. Third number is nature of the material of a conductor. Nature of the materials means one topic or one term we also study in the next class, that is called resistivity. Okay, that depends upon the nature, because different resistance, a different conductor has different resistor. Iron, aluminium, this different conductor has different resistance. So that resistance depends upon then which type of conductor this one. What is the metal of this conductor? Okay, so nature of the material of a conductor is directly proportional to the total resistance R, and this is an intrinsic property, okay, of a material, because it depends upon the material, which material we used here, iron, nickel, cobalt, which one. Okay, now next one is fourth number is very important, temperature. Mainly this one, length, area and temperature. These three is the main point, main factors. How temperature related to resistance? Temperature is directly proportional to the resistance. That means if we increase the temperature, resistance also increases. How resistance is increases? So before we discuss how temperature is related to resistance, first we study that what is the cause of resistance. What is the cause of resistance? We know that in a conductor there are many free electrons which move inside the conductor randomly. Suppose this is a conductor and this one is a atoms and this dot one is a electrons. So in a free electrons mean outer shell electrons. This called free electrons. These free electrons move randomly inside the conductor. Okay, so during this random movement, they collide with each other and also collide with atoms. They collide with each other, electrons to electrons, and also collide with atoms. Then what happen? If we apply an electric field between the 2 points of a conductor, here we applied a electric field, that means it is connected to a source, battery or cell. When an electric field is applied between the 2 points of a conductor, they try to move opposite to the field. Okay, but due to that collision, because of their random motion, the electrons can't move freely because of that collision. And when they can't move freely, they produce a resistance, or they opposes the flow of electric charges or flow of current. And we know that the resist of a flow of current or opposites of a flow of current is called resistance. So this is the main reason behind the cause of resistance, how resistance occurred. So in a conductor, there are many free electrons inside the conductor and they move randomly. During their random movement, they collide with each other and also collide with atoms. Now if we apply an electric field, they try to move in an opposite direction of the electric field, okay, because they are the negative charge. But due to the collisions of the electrons to electrons and electrons to atoms, they cannot move freely or easily, and this is the cause of the resistance. Okay, clear? Now how temperature affect on this resistance? What happen when we increase the temperature? What happen inside the conductor? As the temperature of a conductor increases, the collision between the electrons increases. They randomly move, and during their random movement, it is a normal temperature, this diagram. Okay, at normal condition, they move randomly, and atoms, these are the atoms, they are fixed in their own position. And because they are the metals, we know that the metals, in the atoms of metals are tightly bound together, and the interatomic space between them is very less. Okay, so as the temperature of a conductor increases, what happens? The collision between the electrons also increases, and due to that collisions and due to the increase in temperature, what happens? These atoms vibrate in their own position. The vibration of the atoms also increases. This is a fixed position. There is no vibration inside the atoms. But as we increase the temperature, their collision also increases between the electrons. And what happened? The atoms also start vibrating in their own position. So what happened? When it vibrates, it blocks the path of the electrons, and sometimes the electrons also collide with the atoms. Okay, so when they collide with atoms, what happens? They can't move freely and they increase the resistance. As we increase the temperature, this vibration also increases. So as the vibration also increases, the number of collision also increases. If the collision increases, that means the electrons can't move freely or easily inside the conductor. They block the flow of electric current. Okay, and resistance also increases. Okay, as the temperature of a conductor increases, collision between electrons increases. Also due to increase in temperature, the vibration of the atom increases, so that the collisions of the electrons with the atom also increases. Due to this reasons, the electron face more resistance to move, or we can say that resistance of a material increase as we increase the temperature. Understand? Thank you.